Welcome, everybody. We will be starting here in about 3 minutes. All right. Well, welcome all you Earthlings to our viewing of Comet Tsuchinshan-ATLAS. I'm probably butchering the first part of that name, so from now on I'll probably just call it Comet Atlas. All right. Well, welcome all you Earthlings to our viewing of Comet Atlas. I'm probably butchering the first part of that name. So I'm not sure why I'm getting feedback here, but hopefully it's coming across okay for you guys. Yeah, it's coming across okay for you guys. All right, so what I'm going to do is we'll start off here. So the Comet Atlas has been around for a little while. It started off as a very great object in the southern hemisphere, and so they were able to see it quite a bit. And then it transitioned into the morning for the northern hemisphere. And so, if you were able to get up in the morning, say probably over the last month or so, You probably had a chance to see it in the morning. And then on October 11th, it transitioned into prime time in the evening. And so we've had it in the evening, and it's gotten progressively higher and higher as we go. And but it's also getting a little bit dimmer. And I'll kind of go through some of the background on the comet and comets in general while we're waiting for Bernie to get things going. So I am Jim Noel. I am one of the members of the Tucson Amateur Astronomy Association here in Tucson, Arizona. And I'm here along with Bernie Stinger, who is using his telescope with a camera and a hyperstar. And then we also have Jim O'Connor that's on YouTube that will be helping to answer comments with you guys and let us know if there's any issues going on. So I'm going to turn it over to Bernie and give him an opportunity to talk a little bit about his equipment. And then while he's finished tweaking his telescope, we'll talk about a few other things. Helping to answer comments with you guys and let us know if there's any issues. So I'm going to turn it over to Bernie and give him an opportunity to talk a little bit about his equipment. And then while he's finished tweaking his...
Yeah, you've got a long time delay there, Jim. Anyway, can you hear me all right?
Yes.
Oh, good. So my name is Bernie Stinger, and I'm also a member of the Tucson Amateur Astronomy Association. And I'm currently outside my home here in just off of Tanque Verde Road and Sabino Canyon area. And I've got my telescope. You can see the picture there of, I've got it set up next to me, and that is a 8-inch Celestron on a AVX mount, motorized mount, and I've got a hyperstar on the front end of it, and a camera on top of that. That's what the glowing blue light is at the very top there. And that is a Mellencam 16. Well, there we go. That's a Mellencam 16 megapixel camera. And I've got that feeding back to my PC here. So our project tonight here and what we want to do for you is not show you any spectacular views of the comet, but give you a view of what it would look like if you actually looked through a telescope and were able to see it in a telescope. I know some people in the US, they've got eternal cloud cover, or they're so far north that they don't have a good view of it. We've had, very fortunate, we've had excellent sky here almost every night in the Tucson area. This time of year is very typical. So we have some nice views of it every evening. And I've been watching it pretty much every night as it's been going up higher and higher in the sky. So I'm going to pass it back to Jim here and let him talk about comets in general while I do a star alignment, because I need to get my scope aligned and then find the comet. So back to you, Jim. I'm going to pass it back to Jim here and let him.
All right. Thanks, Bernie. I'm going to stop the share for a minute. I'm still getting a little audio feedback, and I think it's one of my windows that's open. I'm going to see if I can fix that before we move on. Otherwise, I'll just deal with it for the short term.
So back to you, Jim.
Let's see. All right. Thanks, Bernie. I'm going to stop the share for a minute. I'm still getting a little audio feedback, and I think it's one of my windows that's open. I'm going to see if I can fix that before we move on. Otherwise, I'll just deal with it for the short term.
Back to you, Jim.
All right. Thanks, Bernie. Okay, I am back and I have fixed that problem. So now I'm going to get the share going again. And here we go. So First, let me just tell you a little bit about the club while we're waiting for Bernie to get the comet in and get everything going. So Tucson Amateur Astronomy Association, we were established in 1954. We have actually probably around 800 members. It's kind of interesting in that a lot of our membership, or not a lot, but maybe a quarter of the members don't even live here in Arizona. They are scattered across the country, and they'll come join us once in a while to come do some observing under the desert skies. We average about 25 outreach events a month. Bernie and I kind of coordinate those. Bernie does a lot of the public ones. He coordinates the public star parties, the ones we do for the schools. We do them for nonprofit groups. We do them for other organizations and things like that. And then I coordinate our other event or private events. For instance, we'll do weddings. We'll do anniversaries, birthday parties. We support some of the local resorts throughout southern Arizona, and we also do some other types of private events. So yeah, we average quite a bit each month. The club has 3 special interest groups, which helps the members develop. We have one called the Astronomy Fundamental Special Interest Group, and so that focuses on members that are kind of new to astronomy and want to learn more about their equipment and their telescope. And then we have one that's called the Astro Imaging Special Interest Group. And so that helps the imagers in our organization. We have some fantastic imagers tweak their skills and processing for astro images. And then we have one called the Starry Messenger Special Interest Group. And that actually just focuses primarily on outreach events. So the events that Bernie and I do, plus we do some special events throughout the year. We'll do an astronomy festival in March where we do it for the city of Tucson and invite the public to come and do some solar observing as well as some evening observing and bring their telescopes if they want to get some help in using their telescopes and things like that. We also have 2 dark sky observing complexes. One the club owns that is about 100 miles southeast of Tucson near the Chiricahua Mountains. We call it the Chiricahua Astronomy Complex. If you're familiar with the Bortle skies, the Bortle 1 sky is the best sky you can get, really, really dark. A Bortle 5, I think it's 5, maybe it's 10, I think it's a 5, is the bright one. We're between a 1 and a 2. So we have pretty good skies out there. We have lots of observing pads, telescopes. We have RV parking places, sleeping rooms. We have a classroom that we can bring youth groups and schools out to do astronomy events. We have some observatories that members can lease and operate remotely and things like that. So we have a really good site out there, and we have about 16 acres. And then we have one closer to Tucson, but on the west side of Tucson, that we sublease from a model airplane group who subleases it from the city of Tucson. And it's called TIMPA. And TIMPA stands for Tucson International Modelplex Park Association. So we have a couple of telescopes out there and some pads, and it gets us on the other side of the mountains from Tucson and a little darker skies. There's our website, our Facebook, Instagram, and YouTube. Just kind of look Tucson, just do a search on Tucson Astronomy and you'll find us. All right, so that's a little bit about the club. So now let's talk a little bit about comets and what they are. Comets, we refer to them as dirty snowballs. And so they are some of the primordial objects that were created or made when the solar system was made about 4.5 billion years ago when the sun was born. And so comets kind of hang out in 2 general locations in the solar system. One's called the Kuiper Belt, and the other one's the Oort cloud. And I'm going to talk a little bit about both of those here in just a minute, just to give you some background on where they come. So they'll float around out there and do their thing and just hang out. But every once in a while, something happens where they get perturbed and they'll get kicked into the inner solar system. So from the Kuiper Belt, there may be another object or another asteroid or comet or something that perturbs it. The Oort cloud is much further out, so we could maybe a passing star or cloud of gas or something like that might perturb it enough or they might get close enough where something would kick it in. And they would start their journey into the inner solar system. So until they get into what we call the snow line, into about the orbit of Jupiter, we're not really going to see them. Once they get in close enough, though, then the sun starts heating up the dirty snowball. And the dirty snowball is really just rock and ice. So it's just leftover stuff that's usually a fairly loose conglomeration of material. And so it'll start heating up that gas and the ices, and they actually just through the process of sublimation, they just turn from a solid to a gas, and that's what we see as the coma. And that's what you're seeing right here in this one of these examples that Bernie has of one of his previous observations. And so as it heats up, then that is being displayed, and we're able to see it a little bit better as it gets closer to the sun. And then the dust tail will start forming, going opposite direction of the sun, because that's the pressure from the heating that's causing that to blow off, and that creates the tail. And then there's actually another tail that sometimes you can't see quite as well, called the ion tail, and that's usually out in front of it. And that is more from the solar wind and blowing off and ionizing the ions of the coma, and that produces a little tail off the front. So the naming convention for comets is a little complex, sometimes hard to follow. Basically, a name will have the person or the observatory included fairly early on in the name, of who discovered it. And then there's more than three, but there are three common letters that are associated with the codes of a comet. And there's a P, a C, or an I. A P is a periodic comet that has an orbit of less than 200 years and has passed by the sun at least once. So that means that it takes 200 years to come in and go around the sun and go back out again. So that's what we call a short period comet. And we have and then if they're observed multiple times, which less than 200 years, some of them could be observed many times, we'll add a number in front of the P. For instance, one that's fairly famous is Halley's Comet. Halley's Comet, its official name is 1P/Halley. And so the 1P indicates that it was actually the first one discovered of the comets that are listed. And so there's a lot of periodic comets. I don't know, we're probably up to maybe several hundred now. And so each one, as they discover a new one, would have a new number in front of the P once it becomes routine, once it does more than once. And then a C is a non-periodic comet, so that's longer than 200 years, and that it may have only passed the sun once. It's only been observed once. An example of that might be Comet Hale-Bopp, which was C 1995-01. And so the C is the non-periodic, and then I'll talk here in a minute about the year and the other letter and numbers. And then we have a new one that was instituted in 2017 with an I, and that is interstellar. And so that was kind of a new category when Oumuamua, if you remember, back in 2017 was discovered as it was passing through the solar system, and it just kept on going. And so Oumuamua has a name of 1I, because it was the first one and it was interstellar. 2017, the year it was discovered. And then the U is the month of discovery. So for instance, the 26 letters of the alphabet, or the 12 months of the year are divided in two for each month. So January would have the letter A for the first half of the month and the letter B for the second half of the month. And then February would have the letter C for the first half of the month and D for the second half of the month. And that goes all the way through the alphabet. And so in this case, Oumuamua had 2017 U1. So U, if you figure that out, it'll be the first half of November. And it was the first one discovered. That's the O1 or the U1. And so that's kind of how the numbers go. And so that's pretty much it. So our particular comet, which is Comet Tsuchinshan-ATLAS, is C/2023A3. So C means it's non-periodic, which means that its orbit is longer than 200 years. That it is was discovered in the year of 2023, and A3 means A was the first half of January of that year, and it was the third comet that was discovered in the first half of January. And the comet was actually named after two observatories. And once we go to the comet, Bernie brings it up on a scope, we'll talk a little bit more about the comet and things like that. So that's a little background on comets. Let's just kind of take a look at some of the things that I did mention on the solar system. And so here we are in our solar system. We've got the sun on the left and deep space on the right. And so the first four planets, Mercury, Venus, Earth, and Mars, we refer to them as the rocky planets, the inner planets. And then in between Mars and Jupiter, right in here, is the asteroid belt. And so that's the leftover debris of most of the stuff that did not form into planets and was not used up by the sun. So that's the asteroid belt right in between Mars and Jupiter. And then Jupiter, Saturn, Uranus, and Neptune we call the gas giants. And they're the outer solar system. And then just beyond Neptune is poor little Pluto hanging out here. Pluto is now called a dwarf planet, but it is the closest and the largest object we have detected so far in the Kuiper belt. So it's a Kuiper belt object. And its orbit is significantly different than the 8 primary planets. And so there's probably more Kuiper belt objects that will be discovered out, or there are some that have already been discovered, but we'll probably find other stuff once we start training some telescopes on there. And then you've got what's called the termination shock and the heliopause. And these numbers down below, this is in astronomical units. Let me just explain that real quick. So the distance between the Earth and the sun is 93 million miles. And so we call that 1 AU or 1 astronomical unit. So Earth is 1, Saturn is about 10 astronomical units out. The termination shock or the heliopause is about 100 astronomical units out. That's about where the Voyagers are. They're out in this area. I think Voyager 1 actually is in interstellar space now. And so the termination shock and the heliopause is kind of the bow wake or the bow wave of the sun's orbit around the Milky Way. So as the sun in our solar system orbits the Milky Way, we are plowing out the interstellar medium where there's gas, dust, there's particles, things like that. And we're creating a bow wave, basically just like a boat. And so that's kind of what this is. And this is what this is depicting right here is kind of the bow wave of the orbit. And then way out here, there's a spherical cloud or shell around the solar system called the Oort cloud. It's pretty far out here. It's about 1,000 astronomical units out to maybe 100,000 plus. So it goes maybe almost halfway to the nearest star to our sun, which is Proxima Centauri in the Alpha Centauri system, which is 4.2 light years away. So out here in the Oort cloud is a lot of comets that are just kind of hanging out, probably a few asteroids as well, minding their own business, orbiting around the sun. Something might happen where, you know, our solar system might stray a little too close to the sun or to another star or some gas or something like that. And so it could kick and disturb the comets a little bit, and they'd get kicked into the inner solar system. So if you remember when I was talking about the comets, we had periodic comets and we had non-periodics, the P and the C. The periodic comets usually have orbits into the inner solar system of less than 200 years. Like Halley's Comet, some of the ones that come back around quite often. Halley's Comet, I think, is about 86-year orbit. Comes in every 86 years. And so those usually originate from the Kuiper belt out here where Pluto and beyond is. That's the closer in one. That's where the short period, 100 or 200 year or less comets will come from. Out here in the Oort cloud is where the long period comets, or the C, like the one we're looking at, Comet Atlas is. These can take, thousands of years to tens of thousands to maybe even millions of years if they're way out here and they're just traveling really slow to get into the inner solar system. And again, we probably won't see them until they get into roughly Jupiter's location. And the ones that are way out here are coming in at a pretty good speed because they got a long distance to be slowly gaining speed as the sun's gravity starts pulling them in. And so that's where a lot of the long period comets will come from, is the Oort cloud. So that's just kind of a brief review on the solar system. So now what I want to do is I want to give you a quick view of where the kind of an orbit simulation of the of where the comet is. So I'm going to stop this share for a minute. And I'm going to bring that up. It looks like Bernie's got the comet, so we'll get to him in just a minute. I'm going to bring up and show you the comet location. Let's see, now we'll do the simulation first, just so that you can kind of get an idea of. So here's the simulation. So here's our solar system. This is the comet over here. So this is the comet's path coming in and out. Let me just start the simulation. This is back in March. This is from the Sky Live, very cool website if you get a chance to go there. Lots of good information on current stuff. I'm going to play it. You should see the comet coming in from the left. It's kind of diving in above the plane of the Milky Way. See the planets going around. We're now into May, so this is advancing pretty quickly. This is probably when it was visible in the southern hemisphere. And we got June and July, and now it's starting to pass some of the inner planets. August, so it got closest to the sun in the September timeframe. So this would have been roughly about in here is its closest approach to the sun and its brightest. Its closest to the Earth would have been just as it was starting to swing around right here. And that was just a few days ago in October. And now we are seeing this is today and beyond. So this is moving back out again. So now it's in November of this year and out to about December. So I'll stop it there. So that just kind of gives you an idea. The original calculation of this comet was about an 80,000 year orbit, which would have put it coming in from the Oort cloud. But now, based on the current and the fact that they've been able to track it, they don't think it's going to come back into the solar system. So the 80,000 year figure is thrown out, and they think this is going to be a one-time pass. So you definitely want to get out and see it. All right, now let me just show you where it is in the night sky, and then we'll get over to Bernie here real quick. So I'm going to stop this share. I want to show you where it's in the night sky in case you want to go mobile and you want to go out and have a look at it, you can. So this is using a program called Sky Safari. So if you look into the west, you'll see two prominent objects. You'll see Venus a little bit south of west and Arcturus a little bit north of west, fairly prominent. Venus is a really good reference point. And if you look to the upper right of Venus, about 25 degrees. And so if you take your fist and hold it out at arm's length, an adult fist, the width of the adult fist is roughly 10 degrees. So you could go 10, 20, and then another half, and that would give you the 25 degrees. If you're using a child's fist, then you just compensate accordingly. So it should be right up there. It should be visible naked eye. It's pretty dim. If you got a pair of binoculars, that's even better. And then you can also use Arcturus. Arcturus is further away. If you can see the handle of the Big Dipper, that's this guy right here. We say arc to Arcturus. If you're coming off the handle of the Big Dipper, you can arc down, and that's Arcturus. Arcturus is about 35 degrees apart. So that is where it currently is in the night sky. So Bernie, are you ready to start showing the comet?
Yeah, sure. Absolutely.
All right, then I'm going to stop the share and you got it.
All right. coming in pretty decent here tonight. So let me switch over to that one. There we go. Is that coming through?
Yes, it is. Looking good.
Okay, good. Um, a little easier to capture tonight with without the clouds. The other night I was searching for it and cloud cover was a bit of a problem. This tonight it was without the clouds. Um, we were able to acquire it quite rapidly. And I'm going to move that over here. You can see the coma there. Coma is I believe they're saying the coma is around 8 minutes of arc in size, which is a fairly sizable coma. You can see it's much larger than any of the background stars. So let me move that over. And let's take a look at the tail a little more. So I'm shifting the telescope to the right so that you can see more of the tail. I have to do it in little jogs. Don't want to go too fast or I'd swing it right out of the field and then have a hard time finding it again. So little steps is better than nothing. I'd say the tail is coming in better tonight than it was last night or the night before.
Yeah, it's looking great. Not seeing any of the ion tail. I don't know if you're able to see that with your scope or not.
Uh, just barely. It's about the same as it was 2 nights ago, Jim. I suspect that was probably more easily seen several nights ago. Um, I can just make it out here in my view, but through the Zoom transmission, I suspect it's probably lost.
Yeah, more than
But I can make out a slight line going off in this direction. I'm down in this direction.
I used a very active imagination. I would agree with you. Maybe just a little bit of darkness coming across there, but it's kind of hard to see.
Try moving that just a hair more. Now, according to the Sky website, the tail is 2 degrees. I don't know, it depends on how long of an exposure you want to do as to how long that tail would get, but um, I would say that's about 2 degrees because with the hyperstar on my my camera on this telescope, I have about a 3 degree field of view. So that's getting pretty close to two, maybe a little over a 2 degree field.
You can definitely see it fanning out and then it just kind of fades away.
I can follow it out to about here. I don't know if you can, but
That's about the limit I can see
that's
on.
about as far as I can. If I use averted vision and don't look specifically at that spot, I think I can make it out a little bit further. But that's about it. Now there is techniques to bring that out in more and make it more obvious, but it requires a lot of post processing. You have to take a whole series of images and then run them through special software programs that will compound the image and bring out those fainter details more easily. I can't do that on the fly with this software. So that's not something that I could do this evening. If I took images of this and went inside with it and spent some time with them, yeah, it can be done.
So Bernie, do you want to give a little background information on the comet, or I can start? It doesn't matter. We can talk a little bit about the background.
Let me do a full field here. Image. Full screen. There we go. There, that might come out nicer.
Yeah, that looks good.
So, the information that I have here, and I don't have complete information on it, but you can probably fill in what I don't have is right now it's about 54 million miles away. So about roughly half the distance to the sun. So fairly close by, and some comets are a lot further than that. So this is a fairly close by one. If you look at the moon being a quarter of a million miles, so this is about 200 times further away than the moon. The coma, as I mentioned earlier, is about 8 minutes of arc in diameter. And the tail is about 2 degrees, and it looks about right. It right now its magnitude is 4.1. Now, 4.1, um, the average human with good eyesight can maybe see down to 6, magnitude 6. That's a descending scale, so 6 would be fainter than 4. So it's still within range of the human eye. If you look up in a dark sky, you should be able to see it visually. And although I haven't tried tonight, I know 2 nights ago it was visible to the naked eye. And I think, Jim, you said that you were able to see it 2 nights ago as well.
Yeah, yeah. As long as it's faint, but you can kind of use the directions I gave earlier and get close to it. And a pair of binoculars, which a lot of people do own, makes a world of difference. So if you're having trouble seeing it with just your eyes, get a pair of binoculars out.
Yeah, but it still is within range of human eyesight
Yep.
if you're in a dark environment.
Yeah.
Um, According to the website, this one's moving at a pretty good clip. This one's moving at 76 kilometers per second. So it's moving at a pretty good clip, and it's going to be out of here pretty quickly. And I think what are they forecasting? Maybe a couple months, um, and it's going to be pretty much gone from view, except for people with very good telescopes.
And then even in that, it'll probably be pretty dim.
Yeah, and the tail probably be gone or virtually gone because of the distance away from the sun. Do you have any more information on it, Jim?
Yeah, I'll just tag on a couple things. So you're 76 kilometers per second. That's about 195,000 kilometers per hour, which is what I had, or 121,000 miles per hour. So like Bernie said, it's cruising right along. And like I mentioned earlier, the comets coming in from the Oort cloud, which this is one of them, travel at pretty good speeds. And so this one is certainly depicting that. And why? That's why I think as it swung around and picked up enough speed that they've recalculated and decided that it may not be in an 80,000 year orbit like they originally thought, that it will probably be a one-time visitor, and once it goes back out, it might just fly right back out of the Oort cloud and be gone. Let's see. So a couple other things I had, Bernie. The I mentioned earlier about the observatory's name and in the name of the comet. So in this case, this is Tsuchinshan-ATLAS. So Tsuchinshan is a Chinese observatory. So it was discovered initially in China, and that apparently means Purple Mountain Observatory, or Purple Mountain is what the name is, and it's the Purple Mountain Observatory of the Chinese Academy of Sciences. And it was actually discovered by them in in January of 2023. That's why it's got the January tag on it. And then a second discovery a few months later, and they just decided to name it with co-discoveries, was the Atlas system. And Atlas is a US system. It stands for Asteroid Terrestrial Impact Last Alert System. So it is a series of 4 telescopes, 2 in Hawaii, 1 in South Africa, and 1 in Chile, half-meter telescopes that are constantly scanning the night sky and looking for comets, comets and asteroids. And so they're looking for near Earth ones. This is considered a near Earth because it did come in, not real close to Earth, but fairly close. Its closest approach to the sun was back in September. I think it was September 27th, where it got to within about 28 million miles of the sun. And then its closest approach to Earth, as I was showing in the simulation, was just a few days ago. It was like 6 days ago, October 12th or 13th, and it got as close to about 44 million miles or 70 million kilometers from us. So yeah, it was not real super close, but close enough that it's putting on a good show. So that's a little bit of a background on there. What I saw, Bernie, and you can correct me if I'm wrong on this. I saw the data I saw was showing about a 2-mile diameter or 3.2 kilometer diameter coma or nucleus. Does that sound right?
Um, I couldn't say if that's right or wrong. You'd have to sit down with a little bit of mathematics to say whether that's right or not.
That's what they were calculating.
Okay,
We'll
okay.
go with it.
We'll go with it. Yeah,
Yep.
that sounds about right.
Yeah. So it's not a huge comet, but it's not small.
Well, and I think, well, aren't they saying that this is probably its first time around?
Yeah, this is the first time in, and apparently it'll be its last time in.
Yeah, that first time in makes a big difference because there's a lot of volatile ices that have never been melted before by the sun. So when they when it comes in and takes a swing around the sun, those uh, those volatile ices just sublimate immediately and give us these beautiful tails. This has got to be one of the better ones, I'd have to say for quite a while now.
Yeah, I'm hoping that some of you guys watching did get a chance to get out and look. And before we wrap things up with Bernie's view, I will throw up the current location again, so that if you want to go out, it should still be visible, probably until for another half hour, 45 minutes before it gets too low. But it will be, it's still got a week or two good left in it yet, especially with a pair of binoculars or a spotting scope if you don't have a telescope. And I'll kind of back up. I can back up the sky safari that I was showing you and show you day at an increment, because it's getting a little bit higher and a little bit further south each day, so it won't be in the same location tomorrow
Hmm.
night.
Yeah, there's definite shift. I've noticed every night it's enough of a shift that um, it throws you off. Uh, I hadn't looked at it for about 3 days, 4 days. Um, from the first night it was visible, and um, the change was so dramatic in just those 3 days that I was having trouble finding it. Fortunately, I had some other younger eyes out here to help me out. I just tried looking, by the way, see if I could spot it visually. I can't spot it visually. But the sky, I must admit, the sky looks a little muddy tonight. I'm wondering if, for those who aren't in the Tucson area, we had a fairly good windstorm yesterday. It blew up a lot of dust, and I'm wondering if there's a lot of dust up there in the atmosphere yet.
Well, there certainly is around here because we've had some wind the last couple of days, so that's probably not helping our cause any.
No, I mean, I was able to acquire the comet easily enough, but the as far as visually spotting it, no, I can't make it out. Binoculars, yes, but not just naked eye.
Yeah, so I mean, if you
Oh,
got a pair of
oh,
birdie,
we just had a satellite go through.
oh,
One thing I wanted to, you the other night I was looking at it, I had satellite after satellite after satellite. I must have counted at least 15 satellites go through within a 10, 15-minute period. Tonight, I've only seen three.
hmm,
So it must have moved far enough outside of the belt, if you will, of, that it's not being as affected by them, but tonight.
yeah, that's interesting. All right. Well, Bernie, if you don't have anything else, we could maybe wrap up your share, and I'll go back and show everybody where it's at in the sky again, unless you want to have anything else you want to comment on.
You know what I'll do here is well, while you're talking, I'm gonna move over to see if I can find a little surprise object.
Okay, so if you want to
And
stop your share, I'll talk a little bit again about it, and just let me know when. Just come up voice because I may not see the chat, and just let me know when you're ready to go to the other and something else.
all right.
All right, so I am going to bring back up. I'm going to actually bring up PowerPoint first. Let's do this just to show you because I did do a couple of screenshots from Sky Safari. This was as of I think this would have been as of like 7 o'clock or something like that. So it's a little bit different. But so again, here's Venus. You're going up to the comet. If you were to use an analog clock, it would be about 1 o'clock direction, upper right. And
asking if Bernie was looking at it.
okay, and it's about 25 degrees, so that's 2.5 fifths up. And then on the flip side, a little bit further away is Arcturus. It's probably closer to maybe 10 o'clock, 10:30 position clock code from Arcturus, and 35 degrees, so 3.5 fifths. So that's kind of where it is in the night sky. I'm going to stop this share and go back to Sky Safari, and I'll show you how it'll change over the time period. I think somebody was asking where Bernie is observing from. He's observing near his house. There's a little park just outside his house in northeastern Tucson, so that's where Bernie's observing from. And then I'm doing Zoom from and emceeing from my house. So let me see. Let me bring up. There it is, Sky Safari. So here's Sky Safari. I'm going to just kind of zoom out a little bit so you can see the bigger part of the sky. This is, let me put it to now. So this is current. So you can see here in Tucson, Venus is just about ready to set. The comet's getting pretty low. I can actually tell you right now how, let's see how high it is. Maybe I can't get to that screen when I'm sharing. So, but it's probably maybe still 20 degrees high or so in the night sky. So what I can do though is let me go to, so this is 7:16. This is all from Tucson and today's date. So what I'm going to do is I'm going to show you what will happen now. So this will be tomorrow's date. And you see it jumped up just a little bit. And then the 21st is a little bit higher. 22nd is a little bit higher. So it's just kind of going up and above Venus a little bit to the left each time. So that's the 23rd, 24th, 25th, oops, 25th. Get my fingers to work right. 25th, 26th. So that kind of gives you an idea. So even just so the span of 6 or 7 days, it moved up this much. But the key thing is that it is getting higher, but it's also getting fainter. And so it's probably, maybe, I don't know, within a week or two, maybe 2 weeks, if you've got good skies towards the west, you might be able to still make it out visually. But you should still be able to see it as through a binoculars or a spotting scope. And certainly, if you've got even just taking it with an iPhone, I've done some pictures with my smartphone, handheld on like 3 or 5 seconds or something like that. And it shows up. It shows up nicely. You can see a little bit of a tail. The picture that I put on with the event, the little tile that was with it, was the one I took with my iPhone from my backyard, I don't know, about 2 weeks ago, week and a half ago or something like that. So anyway, yeah, it's cooperating very nicely. It's going to eventually get up into the band of the Milky Way up here. That might make it a little bit more difficult, but it's going to be getting kind of dimmer there. So here's Venus. You can see Pluto's out here hanging out by itself. I'm just waiting for Bernie to get ready, so I'll just keep kind of scrolling around. Saturn's up in the night sky. If you haven't had a chance to see Saturn through a telescope, Saturn and Jupiter are absolutely must-sees through a telescope. You can clearly see the rings and see some pretty cool stuff. Neptune's out, so we've got actually quite a few planets up in the night sky. If you're in the Tucson area, we do a lot of public events around Tucson, so you just go to our website and check it out on the calendar and come join us. Some of them want reservations, so just take a look at that and do the best, or let us know via email. Yeah, so that's kind of what's going on. Andromeda's up. It's in a really cool part of the sky. So if you can see kind of high into the east right now is the great square of Pegasus. And then coming off the lower left star of the square of Pegasus, you'll see kind of a V coming out here. And this is the constellation of Andromeda. And so you can usually see these 3 stars right here. So you come down 1, 2, 3, and then you go up 1, 2, and let me zoom in here a little bit. Oops, I'm sorry, I was out too far. This is the 1, 1, 2, 3, and then you come up this star 1, 2, so 3 stars up, and then just above it you'll see Andromeda. If you have a dark sky, Andromeda is the furthest thing you can see with your naked eye, 2.5 million light years away. Out at our Chiricahua Astronomy Complex, we can clearly see it. You can see a little fuzzy spot up there, and that's it. Looks great in a telescope. Hundreds of billions of stars. It's our nearest large galaxy. So in our little group here, we've got the Milky Way that we live in, the Andromeda Galaxy. It's 2.5 million light years away, and then a little bit smaller galaxy than the Andromeda, but still I think considered a satellite or a satellite galaxy of Andromeda, is called the Triangulum Galaxy. And that's down here in the constellation of Triangulum. And so those are the 3 big galaxies in our little group, and then we all have a bunch of little galaxies around us, and we're all slowly drifting together. And so if you were to live, say, 5 billion years, as you looked up at Andromeda, you'd see it getting bigger and bigger in the sky as it gets closer and closer. And then eventually we'll all kind of merge into one big ball of stars called an elliptical galaxy. So Andromeda, Milky Way, maybe even Triangulum, all Triangulum, all of our little satellite galaxies will all merge together into one big galaxy. It'll probably take about a billion years or so to settle down, and then we'll be like a big elliptical galaxy like M87, which has a super massive black hole. The black hole that's in the middle of our Milky Way galaxy is the equivalent mass of about 4 million suns. Andromeda, I think, has 6 to 7 million suns. M87, this huge elliptical galaxy, has the equivalent of, I think, 4 or 6 billion suns. So, I mean, it's just huge. This double cluster over here, or another way to find Andromeda is using Cassiopeia. So here's the kind of the W of Cassiopeia, which most everybody can see in the night sky. If you use this steep triangle part of Cassiopeia, it kind of points almost, not directly, but it kind of points towards the Andromeda galaxy. So you can use that. Bernie, you ready?
Yep.
Okay, I'm going to stop the share and you got it. And then we'll wrap things up.
Well, what I did was I ran over to Andromeda Galaxy real
Oh,
quick.
cool.
And unfortunately, this is through my tree.
Oops.
Yeah, I've got a big pine tree just in that direction. So, but it's stuck through it anyway, barely. But yeah, it's there. I've had it better, but here's the core of the Andromeda Galaxy. You can see some of the shape of it going up and back here. You can see some of the dark lanes here going through some of the spiraling arms. Quite faint, but like I say, I've seen it better. Over here is a little fun galaxy. This is M110. It's a very small dwarf galaxy, Messier 110. And it's always fun to spot that too. It's much smaller than Andromeda and far fewer stars involved with that. And this one here, I believe, is M33.
M32.
Oh, you're right. Yep, that's M33. M32. Yep. Also Messier 32. That's a elliptical galaxy, correct?
Yep. Yeah,
And
small elliptical, dwarf elliptical.
all three of these are 2.5 million light years away. These two dwarf galaxies are gravitationally bound to the Andromeda galaxy and travel through space with it. So just thought I'd throw that in there at the last minute.
Well, while you're sharing it, Bernie, I think there was some discussion about whether you're doing any processing. And it looks like right now you're just exposing, right, for a certain amount of time. So why don't you maybe take a couple of minutes to talk about your process here, and then we'll wrap it up.
Yeah, I'm not doing any processing at all, other than a little tweaking in the histogram. If you look over to the left here, you can see the histogram window. The histogram allows you to stretch and also reduce background. So I'm going to drop that histogram way down. You'll see it just washes right out. So by messing with the histogram here, we can move the black level and affect how the contrast of objects. And let's see what else. I've been also adjusting the white balance a little bit to get the white balance in to a nice level. And that's about it. That's all the processing that I've done tonight. This is on the fly. this is all on the fly. So when you do it on the fly like this, processing is, it can be done. I mean, there's a little more I could be doing, as far as, uh, stacking, some average stacking probably would help the image quality a little bit, but I don't think that you could tell the difference over YouTube.
Yeah. Yeah. Otherwise, yeah, some of your fainter ones when you're doing live star parties and in person, you'll do some live stacking and that'll help build the picture up. But here are just the straight exposures have been pretty good. All right. Well, thanks, Bernie. Stop your share and I will wrap things up.
There you go.
All right. So I'm just going to throw this slide up and I'll say a few words and give Bernie a chance to say anything. But yeah, so I'm glad. Hopefully, we had the good crowd. I didn't get a chance to go over and see how many we had on YouTube, but appreciate you guys coming. We just decided, kind of short notice, that this would be kind of fun to do. I'm sure there will be more streams coming in the following few weeks of the comet. Ideally, if you can get out and see it yourself, that's better, because it's always better with your own two eyes. But I'm glad we've had the opportunity to do this. We will be doing another virtual star party November 22nd. So next month from 6 to 8 p.m. We'll have a couple of telescopes on here. And so one will be Bernie and then Jim O'Connor, who's been on the YouTube channel, and maybe another scope or so. And so we'll have some objects that we'll be able to walk you around and show you in the night sky. So that'll be kind of fun. There's all our social media digits if you want to go to any of those. We do, try to post some stuff on Facebook and Instagram of happenings in the night sky. So if we have, a meteor shower or something special happening, we'll throw them out, usually at least on Facebook, but sometimes both of them. And we'll do some pictures on Instagram of our star parties and things like that. We do. We have lots of kid-friendly telescopes and activities, and like I said, we've got all the star parties we got going on and things like that. So come and join us when you can. And Bernie, do you have anything else you want to say?
I just wanted to thank everyone for checking in. Like I said earlier, what we wanted to do here tonight was give the opportunity for those who don't have a telescope or in a location perhaps that have too many clouds or too many trees, and just give you an opportunity to see what this would look like through a telescope. So thank you for coming.
Thanks, Bernie. And again, thanks to everybody coming, and have a great night and a nice weekend. And come join us next month if you want to, or you can check out our YouTube channel. We've got other activities, other stuff on there. We stream our monthly meeting to YouTube as well, so it's on there, as well as the imaging special interest group and the fundamental special interest groups. You can, if you want to learn more about telescopes and astronomy and imaging, those are great. If you want to join the club, we'd love to have you. And our dues are very, very minimum. So anyway, appreciate everybody coming, and we'll sign off now, and we'll see you at the next one. Good night, everybody.